Chad and I were talking about your PhD write-up, and we noticed that you were using terminology like roadmaps and OKRs and stuff like that. And we were kind of curious, like we never really thought about a university running programs like what we see in corporate America with OKRs and roadmaps and things like that. So is that fairly normal, or is that just kind of how you did it?
Did you read my dissertation?
The prep goes deep here. We go deep background.
Having worked with really massive data sets at CERN, like I knew that I could do this job no problem. And I knew that I had a lot of the skills that I needed to do this job. And so I wasn't going to put up with any, oh, you're a fresh graduate kind of thing. So I made it a goal, speak in the language that the interviewer would understand and appreciate and like is like this. So it was a very purposeful, intentional decision to take all of those skills and be able to represent them in corporate speak or business speak or startup speak.
So when you're doing research at a university, like do you actually put milestones in the ground and try to think in terms of like a roadmap where I want to get to? But it's got to be like time bound, right? So it's not endless, I don't think.
Right. I mean, research isn't actually endless. Like, yes, of course you want to keep learning on a topic, but you do have milestones. Like you learn the answer to a broader question, and then you know what narrower question to ask, and then go iterate and so forth. So it's definitely milestone driven. And also, since I worked in experimental physics, but we would work very closely with the phenomenologists who were coming up with the theories and sort of going back and forth because the experiment helps constrain the theories. So it was a bit more perhaps structured than if you were like doing pure theoretical work where you are really throwing things out there. So in that sense, we knew that we wanted to do a certain kind of analysis in order to find a certain kind of signal, which would help us constrain a certain parameter in a theoretical model. So in that sense, when you know that this is the kind of analysis you want to run, it's a bit easier to say, okay, in order to get those results, I'm going to have these 5 steps. And then the other aspect of it is in a particle detector, like the CMS detector at CERN, there are almost routine stuff that you have to check off when you're doing an analysis. So for instance, the detector has hundreds of millions of different components, and some of them are going to be down or dead at any given time, and you can't really go in and fix it right away. So knowing sort of the known unknowns, like where are the gaps in my detectors, how do I fill them, how do I interpolate between the parts that are working, what is the overall efficiency of my detector? It's not going to pick up all the particles that are created. So those things are also a little bit sort of straightforward in some sense. You're not planning out the roadmap in the same way. You're not like, okay, this is, my final result is going to be here in the path to it, I'm going to do these things. It's more, these are the set of things that need to happen. And then as a team lead, when you're having a team of 4 or 5 folks, who's, you have to play to the strengths of different folks. So I don't like doing anything really in isolation. So I wasn't doing research in isolation either. I tried it for a summer. I worked with a theorist and it was just them and me. And it was kind of miserable. So then I found a research group where it's more like sort of group oriented, team oriented. And so that sort of team experience and delegating to different people's strengths, the different parts, like all of that I learned in grad school. And that's definitely paid off in industry as well.